Okay, about this question, I'm given if cotan theta is equal to 2 and cosine theta is less than 0, find sine theta and cosine theta. First of all, think about the quadrant. In which quadrant is cotan positive, which means tan is positive, while cosine is negative? I think it's obvious that I am in quadrant 3 because this is where tan is positive and cotan and everybody else is negative. Okay? So when I find sine theta, I must be sure that its answer should be negative, and cosine theta is already mentioned here, and according to quadrant 3, I am sure that sine and cosine, their answers must be negative. So this is the first step. Okay, which identity will I think of? I'm thinking about one of the Pythagorean identities. You might think in a different way. You might think about, for example, a quotient identity. But quotient identity will not help me here because cotan is going to be cosine over sine, and I don't know wala cosine nor sine, so it's not going to be helpful for me. So I would rather go to one of the Pythagorean identities, which is cotan squared theta plus 1 equals cosec squared theta. I might think, and I'm still trying, I might think this will be helpful for me because this will help me get sine. Okay, now I know cotan squared theta is going to be 2 squared plus 1 is equal to cosec squared theta. And remember, we put the square above the cosec, not above the theta. So cosec squared theta is equal to 4 plus 1, which is 5. So cosec theta, when I come to root, I will have to write plus or minus root of 5. Okay? So this was one of the Pythagorean identities. How will I think again? How will this be useful to me? I will go with the cosec to one of the reciprocal identities, which says that cosec theta is equal to 1 over sine theta. And this is a reciprocal identity, right? Because I want to find sine. Okay, I don't want to find cosec, but I can help me get the sine. So now, to get the sine theta, okay, so now that I have plus or minus root of 5 is equal to 1 over sine theta. Okay, I can swap places over here, or from the beginning, maybe I would have used sine is equal to 1 over cosec. Anyways, the final answer is that sine theta is going to equal to 1 over 1 plus or minus root of 5. But is sine positive or negative? We said sine is negative in this quadrant. So in simplest form, this can be written as root of 5 over 5. And do not forget, it's a negative. Good. So now we found the sine theta and it's negative. Another thing now that I can start thinking of maybe, and you should start thinking of as well, is one of the reciprocal, actually quotient identities. Cotan theta is equal to cosine theta over sine theta. And this is called quotient identity, okay? So now, I know cotan and I know sine, and this is going to be very helpful for me to find cosine. Maybe someone else would want to take this and use a Pythagorean identity, sine squared plus cosine squared is equal to 1. And you will also get cosine. And make sure cosine is negative. So there's no one way. However you think, or which identity you think is going to be helpful for you, use it. I think this one is easy for me over here. I know cotan is 2 equals to cosine theta over negative root of 5 divided by 5. Okay? To isolate cosine theta, I'll take this as a multiplication over here, and I would automatically get my answer as negative because I already fixed the sign of the sine. I mean that it's negative, okay? So equals to 2 times negative root of 5 over 5, and that is going to equal to, in the end, Okay, in simplest form, it's going to end up in negative 2 root of 5 over 5, and this is going to be cosine theta. I'm sorry, you're not seeing. Okay, and this is going to be cosine theta in the end. So I found cosine theta and I found sine theta. There's a way to check this question, maybe as a quick check. I know that sine squared theta plus cosine squared theta is equal to 1. So give it a try and try to square this negative root of 5 over 5 squared plus the sum of this as well, negative 2 root of 5 over 5 squared, and make sure that the answer will equal to 1 and you are trying to check that your answers are right. That's it.